Alright guys, this is problem number 16 in the homework. In this problem, you are given two statements, A and B, and your job is to determine whether they are logically equivalent. So now, how do we determine whether they are logically equivalent? In this particular section, we are going to compare the truth values of these two statements. So therefore, we have to translate both statements symbolically. So here, let's begin. Bob is both a math and computer science major. So see that this is my first statement right there of part A. And this is obviously a connective. And this is another statement in part A. N is the math major. Now this is another connective. But means and, right? It's the same as and. And N is not both a math and computer science major. So this is actually the third statement in part A. So this part A, this whole statement is consists of three little statements, and they're connected by and. Now I would like to define my statement, so I do a little preliminary work here. I'm going to say B represents Bob is both a math and computer science major, which is this guy. So therefore this is the statement B. N is the math major. I'm going to define this as my M. Basically it comes from the math major. M means N is the math major. Now the third one, N is not both a math and computer science major. Well, the way I define it is I define statement A as letter A, B, N is both a math and computer science major. Well, you may wonder, can I like define this is not both a math and computer science major as A? That's completely fine. You will just have a little different. When you write this in symbolic form, it just looks a little different, okay? So it will certainly be okay. But I think in your homework, the suggestion is to define this N is both a math and computer science major as a letter. So I'm going to call it letter A now. Now, first of all, let's translate the part A into symbolic form. So this is my A. Bob is both a math and computer science major. This is my A. And that means, I'm going to write this down here. A M means here, right? I'm sorry, not A, B, but B. That's the statement B. This is my statement B. Okay. N means the connective N. N is the math major, which is the letter M. And you do see that this is separated by comma. That means these two are together. Therefore, I should, when I translate that symbolically, I should put a parenthesis to emphasize that these two are together, right? Now, comma, that means I begin a new one. But means and, so I put an and there. And remember, A means N is both a math major and CSC major. So here, the statement in the parts in the part A is N is not. So it's going to be not, N is not. That means not A. So it will be not A. Alright, so this is the symbolic form that I translated from part A. Let's take a look at part B. We are going to translate that here. And then we are going to construct truth table for this piece and for this piece. Okay, and then we compare the truth values. Now, it is not the case. That means not, right? Not. That means it is not the case for all following. So I'm going to put the parenthesis right there. Both Bob and A are both math and computer science majors. So in other words, that means if you look at the way I define it, that means it is not the case Bob is both a math and computer science major, and Anne is both math and computer science major. So therefore I would say B is not the case, B and A, right? So that's what we got for the P step before this comma. So I'm gonna write this here, not B and A. But means and, so therefore this but means and, so therefore I need to translate to and. It is the case that Anne is a math major and Bob is both a math and computer science major. So Anne is a math major, which is this letter M, and Bob is both a math and computer science major, which is my letter B. Okay, so now you just need to compute the figure out this truth table, because there are 3 variables. We need 8 rows, and usually that's how we begin with our truth table. 4 truths, 4 falses for the B first letter, and true, true, false, false, true, true, false, false, alternating for M, and the last one is just true, false, alternating. Now you can certainly divide this table into different pieces, but sometimes I like to do that just in one column. So the trick is you're gonna identify the order of operation, right? So because these two is they're grouped by parentheses, so you can do this first. So I'm gonna do this first. And not also has a higher priority. Actually, you can do that at the same time, but I'm gonna just label this as my second one. You do that next. And this n has the lowest priority, so we should finish this table. The column, the final column should be right below this n. Okay, let's do that. So B and M, it is true when both are true, otherwise it's false, right? So we're going to identify where they are both true. You can certainly pause the video and then figure that out yourself. And only these two, they're both true at the same time. Otherwise, at least one of those is a false. So I know it's going to be false all the time for the rest of the rows. And let's do the second one. Second one is not A, so we just negate this column. That would be easy. False, true, just alternating. And the last one is an and, so I'm gonna use my red color to highlight the last one. So it is true when both are true, so let's identify this has to be true because both are true. And otherwise that's it, right? So for the rest of those, that's gonna be false. Okay, finally, let's look at the second piece. We are done with the first one. The second one, let's identify the order of operation. So these two are groups by parentheses, so it should have the first priority. Similarly, this one also has the first priority, but I'm going to do it one by this after this one, so I label that too. Now not has higher priority than the and, so this one should be done. The negation of this B and A should be done the next. So this is, I'm going to label that as 3, okay? And finally, this will be 4. Okay, B and A. So B and A, look at B and A. It is true when both are true. So let's skim through. So this is going to be true. And this is true because both are true. Otherwise, they're all false, I believe. Okay? Otherwise, they're all false. Okay, the second one, M and B, right? M and B, well, we actually did the M and B, B and M here, so we can just copy that down. True, otherwise it's going to be false. The next is going to be negation of this guy. That means we're going to negate all these truth values under the n, so we are going to negate it. I'll pick a different color. I'll use false, just simply negate this guy. So this becomes true, false, true, 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 true. Okay, finally, look at these two columns, this column and this column, and the operation is the AND. Okay, so we look at these columns, and it is true when both are true. So do you see that only these two are true at the same time? So therefore, this is true, otherwise it's false. So because just compare these, part A has these truth values, which is identical to the truth values here. So therefore, we can conclude that they're logical equivalent.